Hey, and welcome to this week's lab. Today we'll learn how to calibrate a pH meter, find pHs of different solutions, understand what a buffer is, and understand what a weak and strong acid is. In order to calibrate the pH meter, first rinse off the probe with distilled water in an empty waste beaker. Then place in the buffer solution. Next, on the screen, since we use buffer 4, we will type in 4.0 and press calibrate. After that, your pH meter should be 4 or somewhere close to 4. Next, we will wash the probe again with distilled water and place in the buffer 7 solution. Go back to settings, press calibrate, type in 7.0, and your pH meter should be at 7 or somewhere close to 7. Here we learn that a buffer is a solution that barely changes pH once we add an acid or a base. This is because a buffer is a mixture of a weak acid or a weak base. Buffers work by replacing a strong acid or base with the weak one. To learn more about pH, we tested 2 solutions. First was apple juice, and the next was orange juice. In between testing both of them, we made sure we cleaned the probe. Here are the results. pHs less than 7 are considered acidic, whereas pHs that are more than 7 are considered basic. Also, a pH that is equal to 7 is considered neutral. Since we will not be using the pH meter for a little bit, we are going to store it. You're going to rinse the probe again, and then you're going to place it in a beaker of water. Next, we made 2 sets of dilutions from 2 different acids, acetic and HCl. The first one, acetic acid, is considered a weak acid, and the second one, HCl, is considered a very strong acid. After making these dilutions, we took the pH from each sample. For acetic acid, pH increased as we diluted. This is because when an acidic solution is diluted with water, the concentration of H+ ions decrease and the pH of the solution increases. pH also increased in our HCl dilutions. This is because adding water to an acid reduces the concentration of ions in the solution, causing pH to increase. Now, the difference between these 2 acids is that HCl is a strong acid, whereas acetic acid is weak. On the left, we have a strong acid. That means it is able to completely dissociate in water, whereas a weak acid, as seen on the right, never or barely dissociates in water. In conclusion, a strong acid will fully dissociate in water to form H+ ions. After dilution, only a very minute concentration of acid itself remains in the solution, as most of it dissolves into ions. A weak acid, however, undergoes a reversible reaction, as it only partially dissociates. Because of this, the Ka for weak acids is very small, whereas the Ka for strong acids is really large. Well, lab is now over and it is time to clean up. First, we will start by putting the bottle back on the pH probe. Then we will take our beakers and wash them carefully with warm water and soap. When we leave lab, we learn the difference between a weak and strong acid, what a buffer is, and how to find pH. And we learn how to calibrate the pH meter. Well, that is all for today, and always remember to stay curious.